So this is the source code for an interface, for specifically the java.list interface, or the java.util.list interface. Let me move it aside for a second and go into here. Right? When we create a list list is equal to new, specifically I'm going to make an array list over here, right? And I'll import this. You can look at actually all this code online, right? I've imported list and array list. You can look at all this code online because Java was made to have the source code freely available. So here we go. You've got basically, and notice that actually if we look at this and you can skim through this, most of it's actually comment. Let's see. So comments over here, permissions about it. Oh, here's an uncommented thing saying it's in package java.util. In other words, what folder structure it is, where you can find it, right? When you import it, you go java.util.list right over here. Okay. All the requirements for it. So notice that this is an interface. Now, interfaces are essentially blueprints for creating classes. They say in order to be this type of thing, you need to implement all these functions that I have listed below. So now what's important to know is that the big thing between lists and classes is that lists are abstract. I cannot do this. Error. Implement the methods, it says. List is equal to new list. List is abstract. It cannot be instantiated. You cannot create a new list. Why? Well, as we go and look at this, notice that all these functions that we have here, void add, right? Not having public or private, that's perfectly okay. But we see void add int index EO, whatever that means, right? We'll find that. We'll know what that means in a bit. But notice that instead of going open curly brace and then having code, it just has a semicolon over here. It's like a small method stub. Doesn't actually exist yet. The method hasn't been written. But what we're saying here is that this method is meant to be written at some point. Same over here. Boolean add EO. The method is meant to be written here. So these are all. So what an interface contains are a bunch of methods that you need to implement if you want to be a list, if you want to be considered is a list, right? As a, an is a relationship. If you want to make a class that is considered to be a list in Java, you need to implement these things. The extends over here, interfaces can extend a collection, they can extend another interface and say basically a list is a type of collection, but they can only do it to a single one. So we're saying in order to be a list, you have to program in a void add method. In order to be a list, you have to program in a Boolean add method. We'll learn the differences between them. An add all method, and this kind of looks scary, but trust me, it's not as scary as it seems. There's a clear method. You have to have contains all, an equals, a get, a hash code method, an index. All these methods, you have to implement them if you want to write your own, if you want to write a Java authentic list. So let's go ahead and take a look at the code for array list. Let's go ahead and see. Can we make this easier to read? All right. So here is the source code for array list. And I suppose now's a good a time to mention what does this E over here that was here for lists and array list was. This E over here means that it takes in a generic type, meaning it is a list of something. So this will, when you create a list, it will be a list of strings, or a list of integers, or a list of objects, or a list of scanners, or a list of whatever you want. Well, as long as it's not primitive. More on that later. So public class array list extends abstract list. So basically a list is a type of abstract list. And an abstract class, we're not going to really get into it, but it's somewhere between a interface and It's basically the halfway point between an interface and a class. And actually, I will go ahead and take a look at that. So just so you see, abstract list source code. And yeah, that's from 7, but whatever. So notice that basically it's called an abstract class because we use this keyword abstract. And what it's saying is, just like an interface, you cannot implement it. So public abstract class, abstract list extends an abstract collection and implements the list. In other words, we are implementing a bunch of methods, but not necessarily all of them. So E has been implemented. This has not been implemented, though. I mean, it throws an exception. And the difference between an abstract class and a regular class is that basically some of the methods will be abstract, although it doesn't look like it is the case in there. Ooh, interesting stuff in there. Whatever. Not germane to this. But the point being is that ArrayList not being an abstract class means that you have to put in all the methods, and we'll be seeing what that looks like. And also it implements list, random, access, clonable, and Java serializable. So here's something to notice. You can extend only one class, but you can implement as many interfaces as you want. In other words, you can be descended from as many interfaces as you want, because an interface is just a bunch of method stubs. It's just saying these are all the things you need for a list. The reason we can't extend more than one class is because you might have a conflict between the methods. But if you have a conflict between stubs, who cares? They're just stubs. They're not implemented yet. Right? So source code over here for the list, and notice that it does actually, have methods over here. We have a index. There was an index sub method that we just passed, but there's an add method, right? So all this stuff is implemented, right? To implement an interface yourself, to make a new class that implements a interface yourself, my array list. I'll just create it that way. You just do implements, assuming you can spell, and let's say what do we want to implement? We want to implement list. So we would say my array list E, more on the generics in a bit. And notice I'm getting an error here saying that, hey, my array list, it needs to be either abstract in order to say, hey, you can't implement this class, or if it's not abstract, then I have to implement all the methods. And here they are. All the methods implemented, not correctly, right? But basically, we would have to fill out all these methods in order to make it a valid list. All right. So the important I know that was a lot of information, but what are the important takeaways from this? The important takeaway from this is that when we create a list, like this, which we will do a lot. Why? Because we could implement either this list as either when we have this more general type on the left, I can use a more specific type on the right, and then switch between it based on on my needs. So I could do an array list, or I could do a linked list, right? And then since they have the same method calls, it doesn't really matter. I wouldn't have to change any other code. So, but because it's an interface, you can't create a new list. So that's the important thing to take away there. You'll just simply see that notation done. What is an interface? It's a bunch of method stubs that a subclass of the interface needs to implement. That's really all there is to it. So now let's talk about generics.